Evening, I'm Spot On Weather, meteorologist Matthew Euler. Welcome to my latest video. Tonight I'm going to do the latest forecast update per the 12Z model runs on 19 December 2023. And of course, we're on the 19th of December, everybody, and you know what that means. That means this guy right here is going to be coming to town really, really soon. We're literally just 5 days away from Christmas Eve. And Santa is going to be bringing these toys to all the children, the good boys and girls out there, has a sack all full. So what kind of weather can Santa expect for Christmas this year? And we're going to take a look at that in tonight's video, as well as some interesting longer range forecasts. Here's the overview of this video presentation, starting with the update on the stratospheric polar vortex. Then we'll go into the quasi-biennial oscillation, the QBO, the latest update on that. Sea surface temperature anomalies, how they look globally, as well as the various Nino regions, how those stack up. We'll then take a look at teleconnections forecasts for the PNA, the NAO, the AO, the EPO, and MJO. And then we'll get into some of the modeling for the forecasts, and then I will share my final thoughts. Let's start and take a look with the stratospheric polar vortex and what's going on recently with it. This is as of today from the 19th of December 2023, and this vertical dashed white dashed line here represents today's date, the 19th of December, and you kind of see what the forecast here is amongst all the models. Each one of these color lines represents a different model, and you notice how there's a little bit of a steady decline in these zonal mean zonal winds from around 31 to 32 meters per second. By the 22nd of December, those zonal mean zonal winds are down now to about 25 meters per second. And then the models start diverging after the 23rd of December. You can really see the differences. That gives us lower confidence whenever these lines diverge, which we'd expect these forecast models, these lines to diverge into the future. Further out we go, they're going to be more widespread because there's going to be less agreement among each of these models. But in general, we can see there is a weakening trend of the stratospheric polar vortex in the short term, a potential steadying out of the vortex, and then we have divergence here basically in the modeling right around the 27th of December from a little bit of increase in zonal mean zonal winds versus some weakening in the zonal mean zonal winds. So overall, my assessment of this particular chart of the zonal mean zonal winds is we have a weak stratospheric polar vortex. It's very evident in late December into early January. One thing I want to mention about this chart, the lower these winds get in value, the more deceleration or decrease in the zonal mean zonal winds, the weaker the polar vortex in the stratosphere. And in fact, Zach D. Lawrence has actually added on a negative value here at the bottom of this diagram, just to kind of show you how things have been trending, weakening and lessening of these zonal mean zonal winds up at the 10 millibar level, high up in the atmosphere at the 60 degrees north latitude. If we look at the latest forecast from Net Weather TV, this is for the 30 millibar level, by the way, over here on the right. The white solid lines, again, are the height contours. You can kind of see a little bit of an elongation or stretching towards eastern portions of Canada into parts of eastern North America, specifically the New England area, as of today. So we have a little bit of stretching out of the vortex over time, overall today and early this week. And as a result, we see colder temperatures in place across the eastern U.S., right from New England down to the mid-Atlantic at the present time. Now, I don't normally show you this particular graphic from Zach D. Lawrence, okay? This is at the same levels, 10 hectopascal in the vertical, over 60,000 feet above the ground, and it's basically from 60 to 90 degrees north latitude. So this is the stratospheric polar vortex. This is the average temperatures, and you can see the y-axis over here on the left. We have the temperature in Kelvin ranging from 205 to 240. And you also see what some of these colored lines represent, what models they represent, by the way. That also applied to this particular graphic here with the zonal mean zonal winds I already briefed. But the orange line is, for example, is the GFS model. That's that forecast. The kind of like the violet purple line represents the GEOS. The green solid line represents the GEFS, the GFS, the Global Ensemble Forecasting System, the ensemble average. And then we also have this pink line, which represents the fleet numerical. This is their particular EFS ensemble forecasting system, ensemble average. So there's a lot of different models that we look at here, but I want to show you this stratospheric temperature forecast, okay? You kind of see where we're at now. We're about 212 Kelvin for the stratospheric temperatures. We see a little bit of warming here at the end of this week, and then kind of like a flattening out, constant temperatures there from the 22nd right through Christmas Day. And then again, as expected, we have much more divergence or spreading out of these models, the various models on what's going to happen in the stratosphere. I do want to point out one thing here, and let me go ahead and change things up here. Let me see if I can get it here. Okay. I want you to pay attention to this area right here. See this? This is showing an increase in these stratospheric temperatures by the time we get into early January. So even though there's a large divergence or spreading apart of these models, they are all showing an upward trend into the warming situation in the stratosphere. Okay. Now, if we look at the solid green line, that's the GFS ensemble average, and you can see it's the most bullish, and that's why I wrote that here. Stratospheric warming temps for all the models by early January, but the GFS ensemble, the JEPS ensemble, is the most bullish. And then over here on the right, I'm showing you what it looks like here as far as the forecast of how the orientation of the stratospheric polar vortex is going to look at 30 millibars. Now this is for New Year's Eve, 31 December, and you'll notice this white solid contours, these white solid lines here, and you'll notice the stretching is now over towards northern and northwestern Europe by the 31st of December, and I kind of joke around about it here. It's an elongated or stretched out vortex, and I'm basically saying the vortex is taking a European holiday vacation because, look at the differences here, okay? You see how the stretching out is along the eastern portions of North America on today's date, 19 December, but by the time we get to 31 December, look at where this thing pivots to. The elongation of the stratospheric polar vortex has now shifted to western or northwestern and northern Europe by New Year's Eve. Let's now examine the quasi-biennial oscillation and kind of see what's going on with it. And I've already mentioned this multiple times. Let me see if I can get this back. Okay, there we go. I've mentioned this multiple times how the QBO generally tends to play into the weakening process of the stratospheric polar vortex whenever it's in this easterly phase. Really no difference from yesterday's balloon launch, weather balloon launch, or radio sound observation, looking at the zonal winds in meters per second. Whenever these zonal winds go to the negative territory side here, the solid blue line bends to the left like this, that indicates a negative value or easterly winds in the stratosphere, generally above the equatorial areas. Okay, that's the easterly QBO. Easterly winds, it alternates between westerly and easterly winds over a period of about 28 months. And in this winter, we have an easterly QBO. And again, the research that's been put out, it really indicates that easterly QBO phases tend to result in a weaker stratospheric polar vortex. And, one thing I didn't mention back here with the stratospheric polar vortex forecast is this thing could possibly split as we go into early January with more major sudden stratospheric warming. We'll see how this plays out. But we definitely are seeing some interesting things going on with the stratospheric polar vortex, and really the easterly QBO may be the main responsible party for this stretching out and weakened state of the stratospheric polar vortex so far this December. Over here on the right, again, very similar to my latest video, current value of the QBO, not updated as of yet. It's still sitting at about minus 19.80. And again, I show the comparisons here for the last two El Nino winters, 09-10 and 2015-16. And the big difference, people ask me, all right, 2015-16, we also had a strong El Nino. Why was it so warm that particular winter outside of the January blizzard in the mid-Atlantic? We had a positive values with the QBO, or a westerly phase of the QBO. And so, that does not favor any kind of weakening of the stratospheric polar vortex. It did not in this particular winter. So just want to throw that out there. Now let's examine the sea surface temperature anomalies around the globe. And clearly you see the orange coloring here from the eastern portions of the equatorial areas extending westward to the central portions of the equatorial Pacific. Very much an El Nino signature, still ongoing. The current warmest temperatures are sitting right in this zone, right here. This is the Nino 3 region. We've had dramatic cooling in the Nino 1+2 region, and I'm going to show you those breakdowns here in a moment. So we have the El Nino warming waters still situated where they are, eastern and central equatorial Pacific. We still have the above normal water temperatures there up in the northwest Pacific, generally to the northeast of Japan. We have a little bit of above normal waters as well around Indonesia areas, the South China Sea. And then we also have warmer than normal temperatures, ocean temperatures across the western portions of the Indian Ocean. And those are the main points I wanted to highlight. We still have slightly above normal water temperatures basically along the U.S. West Coast. Let's take a look at the Nino region comparisons now as far as where they stand today on the 19th of December 2023. First off, upper left, Nino 1+2 region, CDAS data showing as of 060, today's date, December 19, 2023. You can see where we've gone. The blue line is the history back to September 26th on the left, going to the current date, December 19th. We are now down to just a positive 0.82 degrees Celsius anomaly, above normal water temperatures, only at 0.82 degrees Celsius in Nino 1+2 region. By the way, that is located immediately right off the west coast of South America. We look at Nino 3 here in the bottom right, showing a value of positive 1.69 degrees Celsius. So a lot more robust in Nino 3 as far as the warmest temperature anomalies go. And by the way, this Nino 3 region remains the warmest region, so right here in this location. So technically, when we talk about east-based El Ninos, that would basically be where we have the warmest sea surface temperature anomalies in Nino 1+2, as well as Nino 3, right in these areas. This would favor, let me draw that out here, I'll circle it for you guys. Generally, right in here, this is an east-based El Nino, when the warmest sea surface temperature anomalies are over in these locations. Now let's look and examine, let's take a look at this here. Let's take a look at that Nino 3.4 region. Of course, NOAA uses this area to classify whether we have an El Nino, La Nina, or La Nada, which is neutral conditions. And right now, the water temperatures in Nino 3.4 are sitting at plus 1.44 degrees Celsius as of today. And then over here in the bottom right, I'm showing you Nino 4 region, and that's way out here furthest west, if you notice here in the upper right. Nino 4 region closer to the international date line. Okay, and that value is currently sitting at positive 1.09 degrees Celsius. So bottom line, all of these regions of, where these Nino regions are, we have above normal water temperatures extending across the entire length of these regions. Everywhere we look, Nino 1+2 is probably the coolest of the anomalies where it sits right now. And then again, Nino 3 is the warmest of all the regions. Nino 3.4 is basically just behind Nino 3, and then coming in about third place there as far as sea surface temperature anomalies is Nino 4 region. Let's now move ahead and take a look at the latest teleconnections and see where we're going with these. This is the EPS PNA 50 per term member forecast. But remember that the solid green line represents the average of all the ensemble forecast members. So we're looking at, in general, a neutral condition today here of the teleconnections, of the PNA teleconnections specifically, but that is going to rise and rise and rise up to this positive 3 value by the 26th and 27th of December, and then it kind of slowly works its way down, but it's in no hurry to get to neutral conditions. So it's a mainly positive PNA pattern from 22nd of December right to the first few days of January, according to the EPS model. We look at the European EPS PNA 50 per term members. Now this one goes out to the 1st of February, okay? So 1 February here, going all the way out. And you see what's going on here. We initially start off positive at this area, okay? So pretty strongly positive too, here at the end of December. And then it works its way down to slightly negative by the time we get to the 6th to the 11th of January before working its way back positive again. So overall, the trend in the longer range EPS is showing a positive PNA. Looking at the forecast from the NOAA Jeffs V12 PNA, generally showing neutral conditions to start as of today's date. But again, this is all going to rise up to the positive level here between now and the 26th of December, and it's going to remain positive all the way through the period. Maybe more weekly positive by the time we get to the 4th of January here at the end of the run. And then here, let's switch gears. We're going to look now at the teleconnections NAO forecast. This is the European EPS NAO 50% member forecast. This is not what you want if you want snow and cold in the east. A positive NAO, not good. Okay, we want a negative one. You kind of see it kind of move down the NAO down towards neutral conditions by the 23rd of December. It remains slightly positive from the 24th of December, Christmas Eve, right on to about neutral conditions here at the end of the run around the 3rd of January to neutral. Looking at the EPS NAO 50% members, now this one is more extended outlook up to 1 February, showing a positive NAO, not good. Okay, we don't like that if we want snow and cold in the eastern U.S. We see it going closer to neutral conditions here, generally between 26 December and early January. And then it actually drops negative here, okay? Negative between 6 January and 21 January before going closer to neutral conditions, maybe slightly positive, slightly negative at the end of the run. Looking at the Jeffs V12 NAO 30% member forecast, generally starting out positive again here with the NAO. Again, not good for cold in the eastern U.S. We don't like that. Positive phase, the NAO and El Nino generally gives you some milder conditions overall. It's not super cold. In general, we have a neutral condition here, generally running in this model for the NAO from the 22nd all the way through most of the forecast period. All right, so again, the importance of El Nino and NAO conditions, okay? I'm showing you temperature anomalies in the top picture here is just El Nino only. Okay, so we're only factoring El Nino winters, and generally we have cooler than normal temperatures with the blue coloring here along the Gulf Coast of Florida. The warmest temperature anomalies are up in Canada, right up here. That's El Nino only. Now, if we combine El Nino with a negative NAO, now we're talking, everybody. We got a much below normal situation of temperatures there across the southeast and mid-Atlantic, and then we got a much above normal temperatures across eastern Canada associated with upper level ridging. And then if we get the El Nino positive NAO, and we're fighting this right now, look at the warmth that's kind of overtaken everywhere. And this is very similar to what we're seeing in December so far. This really matches up well, actually. If I were to show you a temperature anomaly chart for December and show you what it looks like in December so far compared to the El Nino positive NAO, it'd be a very close match. All right, so now moving on to the AO forecast. This is the EPS AO 50% member forecast. Again, positive, not good. What does a positive AO mean? That means I have lower heights over the Arctic area and have higher heights to the south over the mid latitudes. Not a good situation to get cold into the eastern U.S. If we look over time, basically we're looking closer to neutral conditions between 23 December and 3 January per this EPS AO 50% member forecast. The EPS AO 50% forecast, this is the extended outlook through 1 February. Now you notice how positive we are with the AO today. That drops closer to neutral by the 25th, by Christmas Day, but then it's kind of slightly positive again, which we don't like, before it drops negative here. Now this is going to be interesting to watch. So between 6 January all the way through 1 February, the EPS extended 50% member 46-day forecast is showing a negative phase of the AO. That could be significant. Now remember, the AO strength, whether I should say the AO phase, positive or negative, really depends on the strength of the polar vortex. If the stratospheric polar vortex weakens and we get some of the propagating energy to come down from the stratosphere to the troposphere, it very well could result in a negative AO, a much colder scenario for the eastern U.S. Now, NOAA Jeffs V12 forecast, AO 30% members on this forecast, showing again that positive phase of the AO, no good for winter weather lovers in the east, and then it's just a general neutral trend for the majority of the period through the 4th of January. Moving on now to the Eastern Pacific Oscillation, EPO, 50% member forecast. We have a positive EPO, not good. We don't like that. If we want snow and cold east and troughing in the east, we don't like this. But we have positive EPO forecasted by EPS, by this model, right on through about the 28th, and then you kind of see it working its way neutral to slightly negative through 3 January. The European EPS, EPO 50% member forecast out through 1 February. This is the 46-day outlook here, showing again the positive phase of the EPO. We don't like it. Positive phase of the EPO means we have a strong Aleutian low pressure system in the Gulf of Alaska and the Northeast Pacific, high pressure to the south of it. Not good for us. We do like this though. Look at what this EPO extend is showing. A negative phase of the EPO from about the 30th of December all the way through about 12 January. We like. And then we go more neutral after that and slightly negative and neutral again through 1 February. And then finally, no eject V12 EPO 30 mature members. No good. Positive. Oh boy, my plus sign. I tell you what, that wasn't very pretty, was it? All right, positive here. More strongly positive to the EPO there on the Christmas day when things are mild in the east. And then that dipped to negative again. Golly, I cannot draw tonight, guys. Bear with me. A negative EPO from the 29th of December through 4 January. Now, let's examine these teleconnections and see what's happening here, okay? So, 2 days ago, things changed here. Initially, things weren't looking very promising. The MJO 2 days ago was forecast to kind of meander in the small center inner circle here. All right, what does a small center inner circle really mean? It basically means that there's going to be minimal impact due to tropical convection and rising air in the tropical areas, okay? And this really wouldn't amplify any chance for us to change over to a colder pattern. Well, things have changed. Things have changed starting yesterday, and now look at this. This red line, follow this red line where it's heading. It's heading from the null phase on the 21st of December, right? It's in the 8 area. 21st null phase, working its way out of the null phase into phase 1 and amplifying here. By the time we get into the 23rd, Christmas Day, 27th, 28th, 29th, 30th. Wow, that's some nice amplification. Greater magnitude away from the center of the diagram indicates more significant impacts. So a phase 1, according to Jeff's model, what about over here on the right, the European model? Same type of situation here. We're coming out of the inner small circle here at the center, the null phase, by Christmas Eve, Christmas Day, 26, 28, 30. We are more strongly magnified here into phase 1. By the way, phase 1 is a colder phase for the temperatures across much of the U.S., but eventually the cold will spread to the East Coast. So these forecasts have major implications for colder temps spreading eastward in late December. Okay, that's the bottom line here. Now, if we were to get out into 3 and 4, oh boy, I don't even want to talk about it, everybody, because that would be more milder type portions of this MJO phase diagram. So let's not go there tonight. We'll keep an eye on it though. Now, let's take a look at the Christmas forecast. You know, if you're traveling anywhere in the U.S., I just kind of wanted to show you the whole entire image. Green representing the precipitation. The greens and blues are precipitation. In general, what we have going on at Christmas Day this year, we have a little bit of ridging that's moving in from the eastern Great Lakes, trying to work its way eastward to New England. Doesn't quite make it to New England, so I would expect the mildest temperatures here on the right, shown by these maroon colors and these brown colors. This is your warmest temperature anomalies, smack dab across the Midwest, Illinois, Wisconsin, Minnesota, Iowa. Forget a white Christmas. It's not happening. And then across eastern Canada, we have anomalously warm temperatures. We do have near normal temperatures along the immediate coastal areas of Virginia, working our way northward to Jersey and Long Island, as well as parts of Connecticut and eastern Mass. But other than those coastal areas, kind of closer to maybe slightly above normal, it is going to be very mild for the Midwest, working our way up towards Wisconsin. You're getting that new snowmobile in Wisconsin this Christmas. You're getting those any kind of cross-country skis. Unfortunately, I have bad news for you for Christmas. It's just not looking good. And you kind of see here where the precip's going to be. The anomalously warm temperatures are over the Midwest on Christmas Day, but if you're traveling west towards Chicago, towards St. Louis, towards Memphis, towards Little Rock, towards Jackson, Mississippi, down in New Orleans, Mobile, and Pensacola, I got some bad news because if you're flying anyway, there is going to be some heavier showers, rain showers. And this is all rain showers in Illinois. There's no white Christmas with these kind of anomalies, okay? The coldest temperatures are over the Intermountain West on Christmas Day this year. The Dakota's working our way into Wyoming, Colorado, Utah. So if you've got those skis in Colorado, maybe you can use those on Christmas Day. But in general, this is what we're looking at for Christmas Day this year. Now, I wanted to mention, now I'm kind of segueing my way into the later part of the interesting forecast here, this video. mild Christmas temps are going to spill over to the 28th of December. So let's keep going. We have a pattern change, everybody, around the 29th of December. I know you probably have looked at social media if you really follow weather closely in the winter, and ad nauseum you're seeing pattern change, pattern change, pattern change. Not to mention the fact you probably heard the word torch a gazillion times over the last 2 weeks on social media. Okay, so let's dissect this, okay? We're looking at a thickness chart here on the left. This is the 12Z European model run from today, the 19th of December. And whenever you see the blue dashed lines, that indicates colder temperatures. Whenever you see these red dashed lines, that indicates warmer temperatures, okay? They actually represent these lines' thickness values in the atmosphere, which is directly proportional to the temperature. But just for your purposes, and to break this down to layman terms, red dashed lines means milder temperatures, blue dashed lines means colder temperatures, okay? So, you can kind of see where these blue dashed lines are setting up camp, right? From extending from the Midwest, working our way south and across the Mid-South, Memphis, Little Rock, northern Mississippi, northern Alabama, northern Georgia, Tennessee, and the Carolinas, Virginia. You see what's going on here. We got colder than normal temperatures now starting to creep in. And just to prove that point, look at this graphic on the right from the same model, 12Z operational European run today, 12Z, showing the green coloring, which is indicative of temperatures in the order of -8 to -12 degrees Fahrenheit below normal across Florida, the Southeast, Tennessee. So you're seeing we're changing some things here. Okay, let's look at Christmas again. See how above normal conditions are in this area here, Southeast. Moving forward again to the 29th of December, just 4 days later, and it's all green over here. That's below normal temperatures, blue below normal temperatures. You see the warmest temperature anomalies now have definitely shifted back to the northwest across Canada. Now, let's examine some of the longer range ensemble charts now. We're going to start with the GEFS, the Global Ensemble Forecasting System. This is for the 28th of December. On the left, I have the 500 millibar height anomalies, and on the right, I have the 2 meter temperature anomalies in degrees Celsius. So let's examine these two charts. The 28th of December, what the GEFS is forecasting is a trough, indicative of colder temperatures. You see the green coloring and the blue coloring across the southeast and mid-Atlantic, right? All right. So that's a big change. Now, let's go back to Christmas Day. That's a big change from this, isn't it? Or actually, I don't have a 500 millibar chart. That's a big change temperature-wise from this. I thought I had a 500 millibar. I apologize. But anyway, whenever you see the green and the blue coloring, that indicates a trough or lower than normal heights in the atmosphere. And those are typically associated with colder than normal temperatures. Also, these types of colorings at 500 millibars, when we look at height anomaly charts, greens and blues, are indicative of stormy conditions. If we look at this maroon orangish color here, this is associated with an upper level ridge. And this upper level ridge is associated with drier and warmer than normal conditions, and it's going to extend northward into west central Canada by the 28th of December. So we got this, let me go ahead and draw this out for you. So what do we have here? We've got this nice ridge, according to the GEFS model, working its way northward across west central Canada. And what's so important about that is whenever you get this height rise or these heights to build up here, okay, there tends to be a downstream trough basically whenever this occurs, and so you get below normal heights here, downstream of the upper level ridge. And of course, the greater this ridge axis or this ridge builds, the deeper this trough is going to become downstream across the southeastern U.S. So we have a major pattern change, and associated with these anomalously lower than normal heights here on the left, we have below normal temperatures generally right here across the Gulf Coast by the 28th. Now you'll notice the warmest temperature anomalies are now starting to work their way back to the northwest, back towards central Canada underneath this ridge. We move ahead now to the forecast from the GEFS for 31 December, New Year's Eve now. Look at the blue coloring here. It's darker blue, which means even greater anomalously low heights along the east coast, along the southeast coast up to the mid-Atlantic. See this darker blue shading? This is indicative of storminess. And then we still have that ridge axis. Now, there's a big difference here. This ridge axis is now shifted further to the west compared to this particular graphic. See where the ridge axis is over west central Canada on the 28th? The GEFS model is forecasting that ridge axis to back up further westward into Western Canada by the 31st. And again, downstream of that shortwave ridge axis, looking at 500 millibars, we have below normal heights and troughing across the mid-Atlantic and southeast. If we look at the anomalies now on the right, according to the Jeffs model, look at the blue shading here. All right, look at the difference here. 28 December, you notice the graphic here on the right, not much in the way of anomalous temperatures here across the Gulf Coast. And over the southeast, not much in the way of anomalously cold temperatures. But now, the Jeffs model by the 31st, by New Year's Eve, much wider area of below normal temperatures. Let's move forward to one more chart from the Jeffs forecast from the 12Z run today. And notice we still have the anomalously low heights, generally along the southern U.S. to the mid-Atlantic. And we have that ridge axis just hanging out right here, everybody. Just hanging out along the far western coast of Canada. So we have colder, unsettled, more stormy conditions across the deep south, the Gulf Coast, and mid-Atlantic. And look at these temperature anomalies here on the right. Whoa, look at the blue coloring now. Much more widespread with above normal temps above that and to the north association with ridging. So really interesting times according to the Jeffs model. Now let's look at the EPS. 28 December, right? Very similar to Jeffs, showing that ridge axis building up across west central Canada. We got a nice trough that's digging into the southeastern U.S., okay, so the pattern change is underway, even according to the EPS here at this ensemble. Look at the below normal temperatures across Texas and Louisiana, Mississippi, Alabama, Arkansas, Oklahoma, Kansas. Look at where the anomalous warmth's located at. It's well up here to the Northwest Territories, northwestern Canada. And it's really impressive the way, let's just watch how this works out. But beneath the ridge, you're going to have those warmest temperature anomalies. Beneath it, we have cooler than normal anomalies. 28th, EPS forecast, New Year's Eve, 31 December. Now we're seeing the similar trend here, retrograding ridge axis to the west. Okay, now it's moving towards the west, closer to the coast of Canada, the Pacific coast of Canada over here. And look at this, everybody. Ooh, yes. Between the lower than normal height anomalies, the blue coloring from the southeast off the east coast, and then you've got a lot more widespread, even more significant colder temperature anomalies across the Gulf Coast, kind of up the coastal Carolina coast for this point in Florida. Looking chilly for New Year's Eve when you're ringing the 2024, the new year. And then you got that nice area of well above normal temperatures across Canada. So this is an interesting situation. I mean, it makes me go goo goo gaga whenever I see this kind of pattern. And I was thinking to myself the other day, this pattern is very similar to after you get a stratospheric warming event, where you get the warmer temperature anomalies to the north and the cooler than normal anomalies to the south across mid latitudes. That's what typically sets up after a major sudden stratospheric warming, where you really weaken the polar vortex. So this is really interesting to watch. We have one more chart to show you. This is the EPS for 3 January. Oh boy, oh boy, oh boy, oh boy. Look at this. From California all the way along the southern U.S., Florida, up to the mid-Atlantic, eastern seaboard. I spy storms. I spy storms, everybody. This is the storm track. My goodness, I can't tell you what. My little pen here is acting really wonky tonight. Or it might just be operator error. Anyway, this is just a beautiful storm track here. It's to the south. This is not going to allow any of the milder air really to come up, because you want to be north of this storm track, where the air is colder up here in the north, okay? And in El Nino, this is exactly what happens. This is exactly what happens. And then look at the ridge axis above that main southern storm track. Look at that baby. Oh, and what's going to happen? Look at the temperature anomalies here. Right from Texas, the Gulf Coast, Louisiana, Florida, up to the mid-Atlantic. Ooh, yes, yes, yes. I mentioned this the other day. This is just a nice pattern, everybody. Just a nice pattern. And to just basically spruce up your Christmas even more, I thought I would give you an extra gift this year. I didn't wrap it, but here it is in front of you. This is an active subtropical jet stream to boot. Okay, so we get these little jet maxes, these higher, these regions of higher wind speeds within the jet axis here. That tends to be associated with increased vertical lifting in some quadrants of this jet streak or jet max. you're going to get nice storm development along this jet max here. Okay, this is the 20. This is what, 27? Yeah, this is 27 December right here on the left, and then this is for January on the right. All right, so this is just looking delicious, just delicious. Look at the orange coloring here. This is the higher wind speeds, and they're over here on the right, associated with these jets, with the subtropical jet. It's getting active. It's going to be active in late December, early January, from the southern U.S. to the mid-Atlantic. This definitely is barking at me, saying we're going to have more storminess across the southern U.S. as well as East Coast. Now, this is what I would expect during El Nino winter. This is what we would expect. And this is why the longer range climate models were forecasting wetter than normal conditions across this area here. Okay, the southeast up to the mid-Atlantic. And it's nailing it for December, by the way, with these past 2 weekend storm systems that have come through. The past 2 weekends, we've got clobbered up and down the East Coast with heavy rain. Okay, now, this is 50% of the equation, everybody, okay? Get a nice active subtropical jet stream. You know what? If I were to do a checklist, I would say check. We got the check in the box for this. This is El Nino. But we got to have those temperature anomalies before I go to final thoughts. We got to have those colder temperature anomalies, and it eventually transitions to that across the southeast up to the mid-Atlantic. See that? All right, so I am going to be shocked. Now, we got to watch the trends. We all know in the weather business this could change. Okay, and again, I am giving you this video based on the 12Z data, the model data from today, 19 December 2023. What's this going to look like, let's say, on 26 December 2023, the day after Christmas? I don't know. But I will tell you, this has been a remarkable consistency amongst these ensemble models. Let's get to my final thoughts tonight's video. Here we go. Let's bullet ties this. Let's break it down. We're expecting a mild Christmas. It's all but guaranteed this year across New England and the Mid-Atlantic. I think people that are posting probabilities of white Christmases in certain locations this year, it's completely meaningless. It's completely pointless, okay? I'm just going to cut to the chase. I've been seeing them in X today posting probability of a white Christmas. You know, it's no chance at all. It's 0%. Why are you going to torture somebody who loves snow with that kind of data? I mean, seriously. If it was a little bit more interesting pattern like what we're looking at in late December and maybe early January, cool. Show me those probabilities of a white Christmas. But don't do it now. Anyway, it's mild. It looks... And as you can tell from the forecast again, if you're traveling, let me go back to it right there. It's going to be pretty much dry up and down the eastern seaboard for Christmas. It's going to be fairly mild. The mildest anomaly is going to be back to the west across the Ohio Valley and Midwest. You're also going to run again into some rain from Wisconsin, Illinois, Missouri, right down through the Mississippi Valley. And the colder temperatures are sitting out for Christmas Day. If you want it colder, you have to go west. They're west of Omaha to really get into the colder temperatures. All right, moving on to bullet point 2. We are going to see what's known as a retrograding. That means the synoptic feature in the upper levels is going to retrograde or move against the normal west to east flow and those prevailing westerlies. That ridge is going to build back west or retrograde. An upper ridge to the northwest is going to retrograde that way toward the northwest, starting a pattern transition around 28 December. This upper ridge continues to retrograde or push westward further by New Year's Eve with a ridge axis extending along the coast of Western Canada, and I kind of showed you that. Now, I had titled a video, I believe it was last year, don't quote me, it was titled Sweet Spot, okay? And this video, I detailed what sweet spot means as far as the positioning of the ridge axis right along the far western coast of Canada. You want the ridge axis to be right there along the coast of Canada, right where the Pacific and Canada meet. It just sets up a really good positive PNA situation with downstream troughing into the eastern U.S. Okay, so if you want to check out my video Sweet Spot, you're more than welcome to. It's right here on the Spot on Weather YouTube channel. You just have to go back and look at my video library. You have to go back and find that last year. Troughing and below normal heights, okay, along with below normal temperatures, that is looking very likely. We have pretty decent confidence level in this occurring from 29 December into the first week of 2024, right in early January. There will be an active storm track. We will have an amped up subtropical jet. It's going to be there. This is going to promote more storminess on the southern and mid-Atlantic routes. The big question, of course, everybody's analyzing this. All right, will that air be cold enough with that southern storm track? Will the air be cold enough? If we get that ridge axis to back up as forecast per the ensembles, back to that coast of Western Canada, right there where the Pacific and Canada meet, we may be able to get colder air to move in as models are projecting. That positive P&A throughout the forecast period, okay? Now, do I mention it here? Okay, I do mention it here. I won't go into what I'm about to mention. All right, so now also, can the Eastern Pacific Oscillation, EPO, turn negative as well? We want that negative EPO because we want to get a ridge building up from the Gulf of Alaska up towards Alaska, and we want it to be a strongly amplified ridge. We want a negative EPO where we have the ridge in the Gulf of Alaska, the trough beneath it near Hawaii, just the northeast of Hawaii. That's a more favorable pattern in the Pacific. It keeps the Pacific jet from just kind of really running into the U.S. When we have that type of setup. We also have to keep an eye on the AO and the NAO. Now, the modeling, as I showed you, is forecasting those two teleconnections to transition to neutral, potential negative tendencies on the longer range EPS into January for the AO and NAO. So we'll just keep an eye on that. One thing that's missing from the 500 millibar charts we examined is a negative NAO. It's just not there. So the MJO is looking more favorable in a stronger magnitude phase 1. We kind of covered that. And that is indicative of colder temperatures spreading from west to east across the U.S. And then finally, I am going to tell you this right now. This has been impressive. Remarkable agreement amongst the ensemble models. The last 5 days, these models have not changed in what they're projecting. Amazing. The lower heights across the southern U.S. and the mid-Atlantic, last few days of December, before the new year, into early January, they've been there persistently. That gives us a higher degree of confidence than normal. Could change, but right now things are looking favorable. And so, bottom line, ensembles are locked in step with each other. Despite how far out in the future they are, this is a higher confidence forecast. We are starting to see some of these operational models also sync up with the ensembles in the longer range time periods. So days 8 to 10, we're starting to see some of those indicators that colder air, lower thickness values are going to start moving in as that pattern changes. We get troughing across the Gulf Coast up to the mid-Atlantic. We're starting to see colder air move into that troughing. Golden question to end tonight's presentation. Can we get enough cold air south into the mid-Atlantic for some winter magic? The more southern storm track again is going to be there, but that's only 50% of the equation. We can get storms all day long with that southern storm track with the juiced up subtropical jet, but we need colder air to kind of meet up with that moisture as that coastal storm forms. I think we will see periods of colder air in late December, but more specifically in early January, moving in from the north. And by the way, we are at the time period. It's not going to take much in the way of cold air this time of year. Our climatological average temperatures, and you can look it up for any location you want in the U.S., late December to mid-January, your climatological high temperatures, for example, are reaching their lowest points of the year. Okay, so we're heading into the right stretch of time period where we can get continental polar air to come down with a dipping polar front jet stream to meet up with a juiced up subtropical jet and a storm system off the southeast coast, and we can get some winter action here, everybody. It's not as difficult. Let's compare it to, let's say, late November or even March. Okay, the sun angle is getting higher in the sky. We're getting longer amount of daylight hours. We're fighting that. We're just fighting a more intense incoming solar radiation, especially let's just say early March. But we're not at this time of year. We're in late December, we're in early January. This is a great time period where we're reaching the lowest climatological average temps. And so we honestly can get away with a continental polar air mass. Does not have to be Arctic in origin. It can be a simple continental polar air mass mixing in with a storm system to result in wintry weather in the mid-Atlantic. In fact, I am going to be shocked if we don't get some type of wintry weather. If these ensemble models for late December, early January verify, I will be shocked if we don't get some sort of winter storm or winter weather across the mid-Atlantic. All right, that's all I've got for now. I wish everybody a happy holiday season. And I will probably not be in office for a little bit. I'll be out of office really from the 22nd to like the 28th of December. I will be out of office. If I see any really cool, interesting stuff coming up with this pattern change, believe me, I will be posting it on social media, on Twitter, as well as Facebook. So if you follow me there, please do so, and I'll keep you updated on what's going on with some of these graphics and what my thoughts are for particular situations. But it's going to be a little bit of time as we head into the holiday season. You know, it's a time to spend with family and you know, create new memories, and so I will not be making any videos probably until maybe the 30th. Maybe the 30th of December, or maybe early on New Year's Eve. We'll end the year with a bang. And so that's all I got for now, guys. There's a lot of interesting things going on. Stratospheric polar vortex, got to watch that, okay? Some significant changes in the stratosphere. Easterly QBO still doing its work, in my opinion, on keeping the stratosphere weak. And then, you know, the teleconnections, we'll continue to watch those to see what kind of direction they head. You've seen the modeling, you've seen my final thoughts tonight. I'm really passionate about this type of stuff, and I really enjoy it. And I really hope you have a great holiday season. Like I said, I want to say thank you to everybody who subscribed to this channel. You know, I started this whole YouTube channel, I think it was 2015, if I remember right. So it's been almost like 8 years, over 8 years, and I put a lot of videos out there on this channel. You can look, I have over 400 videos in the library now. I started off with like maybe 2 subscribers, you know. So thank you very much for subscribing to this channel. And, you know, I'm so close to reaching the 1K mark for subscribers. So close. So please tell your friends about this channel. That's all I got for now, guys. Again, thank you so much. Best wishes for a warm holiday season to you and your family and friends. And follow me on Twitter over the holiday break. I'll continue to post some things in there from time to time. That's all I got for now, everybody. Until next time, take care and God bless everyone.